This is a test. This is only a test. I don't remember the rest of that dumb announcement, but I'm testing for clarity of reading a CRT, since this will be take 2 of the video if it works. So my test was successful. I'm not going to win any YouTube cinematography awards this year, or any other year for that matter, but I had to figure out what it took to take good, or as close to a crisp screenshot of the Spectrum Analyzer and other things, which I would have not done correctly. I had already done an entire video on aligning this SX-71 and had to throw it away because everything was so blurry. So I think I've got the best I can get out of this cheap Chinese knockoff camera without which I would have no camera at all. So I don't have any complaints whatsoever. And so we're going to get into the actual alignment of this SX-71. Let me take this off the tripod. This is Hallicrafters Rehabs, and thanks for watching. We'll continue in just a second. Okay, so let's go through the setup. First, you're looking at the Spectrum Analyzer. I have, to protect it, a Mr. Carlson's Lab Spectrum Analyzer, I would say safety device, which has some 10 or 12 capacitors in series, which gives it about a 4,000 volt protection against any kind of accidental voltages across the unit. This is a Rigol DSA815, and then the signal injection is coming from this that's right, GWInstek AFG 2125, and the way I've set this is sweeping from 420 kilohertz to 460 kilohertz with a rate of 1,000 hertz, or 1,000 sweeps per second. And I've stopped down the amplitude by 20 dB, and I also use this decade attenuator to knock it down another 20 dB. So the required injection point for analyzing, and this is, let me see if I can get this, there we are, is the center stator of the main tuning condenser with just a simple ground. And then on the pickup, and I've been in a lot of different places getting a pickup, and this is just about the best and the only real option for doing a pickup. Now it's really hard to see that, but you see on this last IF transformer, I'll give you the ID in just a second, there is 2 leads that go to the 6AL5, and the one closest to the 6AL5 is the best one, and you have to do a direct pickup for anything to happen. What I have here is just the short diagram of the detection circuit for the SX-71, and the detector can that I showed you is T10, and I had the Spectrum Analyzer connected to pin 4, which is right here on T10. And basically the way it's set up is that you've got a lot of stuff for narrowband. You actually have an FM detector with 2 sides of two opposite diodes, so to speak, for what's called a ratio FM detector, and that's used only in the narrowband FM position. Most of the time, and nearly every other time, you're using just this little small part of the circuit for detection of the AM signal. And even 50 years ago when I was listening to an SX-71, I never had occasion to use the narrowband FM. I have a jig to, tune that up, but and I did play with it a little bit, but it's really not important. If anybody is using narrowband FM, you can send me an email, and then I'll turn on my radio and try and pick it up sometime. But other than that, I see not much use for it today. At any rate, this is my pickup for the Spectrum Analyzer. Now, when you're doing an IF alignment with a Spectrum Analyzer, certainly, you're only going to do the 455 kilohertz IF stage. The first stage at 2.075 megahertz you do just like in the book. There's just no good pickup point. It's actually buried inside a separate can that the 6BE6 is sitting on top of, and there just is no good pickup point for sweeping the 2.075, and there isn't any need for it. But when you're doing IF alignment in general, I look at it, everybody has different ways of doing it. I look at the response curve. Now, the response curve is just measuring, if you took slices, that's a particular frequency, and that's another frequency, and this is another frequency, and so forth. And so, to me, I think of that as an area, an energy area pipeline. And so, in this case, just to erase that a little bit and get into theory, which I'm probably not the best person to do that, but I think I'm right. If I'm wrong, you can certainly tell me. So at this point, if you had the first IF like the red, and the second the yellow, and the third the green, then basically they're only intersecting in here. And so you've got a pretty dull radio when they're intersecting. So you're having to adjust the resonance of each one of the IF cans, both in frequency. And when you adjust in frequency, there's another dimension to this, so that the frequency goes that way or that way in terms of response. But the other dimension is as you get closer to the crystal frequency, that IF can will increase as well. So as I move this green curve this way, not only will I get the benefit of a greater surface area, but I'll also get the benefit of a greater response. And as I move this particular intermediate frequency transformer in frequency this way to where it coincides, the response will increase, and this will be the total signal energy, so to speak, that gets through the IF discrimination stage of the radio. So it's very critical to do this in any kind of radio if you can do it visually, and there's more than one IF cans. If there's just two, it's probably not going to make that much difference. But when there's three, in this radio, it made a huge difference. And all of my work on this SX-71, the radio was always tracking 1 to 2, not 1. It was about 3 or more dB less than the competition by SX-100 or the Japan radio or one of the SX-99s and so forth. It was never quite there. But when I got it right at this center point, the response, in addition to the energy, adds up to a radio that's performing very, very well. Okay, we're back at the Spectrum Analyzer again. Now, on these IF transformers, the top slug is the primary and the bottom is the secondary in each one. And when I went through and did the alignment, they have you start with the secondary of the last IF, number 3, transformer number 3, and then you start, from the bottom to top, and you go back and forth until you get no improvement, and you've achieved what we have here. Now it's important, if you have a Rigol, and probably most spectrum analyzers, we're really kind of taking a Ferrari of an instrument and using it to drive to a mailbox. It's kind of stopped down in all of its capabilities. For example, now on bandwidth, I have it on 1,000 kilohertz, which is a low setting for the bandwidth detector, and the video bandwidth is only 300 hertz, and that gives me really good response. I said, excuse me, there's a reason why I'm wearing a hat. You may have seen that. It's because if you see me without a hat, you'll know that having a cold, I need to wear a hat indoors, and the excuse, I may have to call for something during the video. So on the sweep, I set it at 20 milliseconds, and at the same time it's sweeping at 1,000 sweeps per second on this function generator. And what else to say? Go back to marker, which gives us the best information. The other thing is, on the radio right now, I have it on the sharp crystal position in the narrowest response of the bandwidth. So what I'm going to do now, because you can by the way, the 3 dB down bandwidth is 2.2 kilohertz, and 6 dB, we could just take a look, minus 6, it's 3.3 kilohertz. I'll go back to minus 3, which is what I normally use. Okay, so it's on the sharp crystal position at the sharpest bandwidth. So what I'm going to do is I'm going to slowly rotate this crystal phasing, and you'll see the notch configuration. So the crystal phasing, by the way, when you're doing an alignment, you do it with the phasing at half gained when you're doing it using a VTB VM or oscilloscope or something. In this case, I'm trying to align as close as possible to the crystal. The best response and everything else is measured by the spectrum analyzer, and so I set it for the narrow setting, which happens to be 2.5 past half gained towards, I'll tell you, I have to look around and see. I think it's towards fully gained. And you have to kind of see where the gain. No, yeah, that's right. It's actually halfway between half gained and fully gained. Kind of like waning gibbous, if you're an astronomer, or waxing gibbous. So I'm going to slowly move it towards fully gained. And you can see now the change. You'll see actually there's kind of a notch that wants to show on the lower frequency side. I'm sort of moving it around in that area. Now this notch is not as pronounced as the SX-99 under any circumstances. That's just the way it is. Okay, that doesn't bother me one whit, because this radio is really doing well. Now I'm moving towards the 0 or half ganged position. Oh, okay. Well, that gives me that notch too. Alright, this is half position right here. Okay, no notch. And we're going back down towards, slowly towards the waning gibbous, we'll say. Yes, and you see the notch, pretty strong notch, really on both sides, but on the left especially. And then as we get closer to fully ganged, you see that shift to where the notch is more towards the right side. Okay. And then we just keep going towards full moon, what's what we'll say, fully gained. And this is fully ganged right here. Still a pretty sharp response, but symmetrical on both sides. Now I'm switching quickly around to 0 ganged. I mean, you know, the lowest capacitance. And what you have here is you have a wider response with a little bit of a little dip in the middle, which is not uncommon. Okay. And if I were even more perfect in my alignment, I probably could make it so that the two humps were the same amplitude, but this be good enough. Still moving towards the half ganged position, or 0 on the crystal phasing. And you see that. Now on the broad position, we're back to, let's go back to where we were at the sharp point. Okay. Now this these traces are set first. The first trace is set for video average, and the second one is just clean write, or every time it writes a new trace. Go back to the markers. Okay. So now we're at the maximum response. I suppose I could reset, average reset here. Okay. Now we got the markers. Alright, so let's go to broad crystals reception. And you'll see a drop in response, and it's definite. You can see that with your very own eyes, and the S meter and everything else. It makes a difference how close you get this thing to the, this is actually set at a center frequency of, can you believe it, 455.000 kilohertz. Would have never thunk it. I thought there was at least some error in there. But the whole net of everything, the parasitic inductances and capacitances inside the circuit and all this kind of stuff adds up to 455.000 to 3 zeros come, and unbelievable. Okay, now I'm in the broad position, and I'm at the maximum selectivity, and still it's showing the same bandwidth, or essentially, so maybe, yeah, it's very close to the same bandwidth. So we're going to go to the, toward the waxing gibbous towards full moon here, towards fully ganged, and it wants to make a notch. As we get a little closer, let's see where the best notch is. Okay. The whole response is actually broader. It's the same amount of energy. Okay, so if you drop the peak, the energy comes through more sideways, so to speak. Let's see. Yeah, it's more sharply downward on the right side at this point. At the, we'll call it astronomer speak, waxing gibbous. Now we'll go to the other side, and I'm wanting to see a little notch over on the left side. The left notches are never as pronounced in the Hallicrafters that I've worked with as the right notch. Okay, so yeah, and then we get to half ganged or half moon, and that's what it looks like. It's a broader, the peak is not in exactly the same place, it's actually moved over a little bit. We're looking at a 4.5 kilohertz bandwidth at 3 dB down. If we go all the way to, you know, new moon, nothing ganged, then there's no real difference between that and half gangs. You get about a 4. You're getting in the range of 4.5 kilohertz. So, getting back to the half moon or half ganged position for the crystal phasing. Not as pronounced as a double hump. It's a single hump camel instead of a double hump camel. And again, to try and straighten that out, as you could work on this for days. You could just do, you know, this is what I do for a living. I keep on tweaking those on one tiny bit at a time to get the better response. So I've gone back to the narrow setting, and there we are. For broad, now for normal position, this is where we go. And it's gone back to a more broader and response pretty close to the sharp position in terms of response. You got a 3.3 kilohertz, and basically there is one more adjustment. It's a trimmer right next to the crystal, which adjusts how even the shape, the response, and everything else. And this particular trimmer is not only screwed all the way in, but it's tightened as tight as I can get it without worrying about, you know, mashing mica to smithereens. And I even put in a 7 picofarad capacitor in parallel with it to, you know, give me some adjustment on both sides. And all I did was reduce the response, but it did allow me to adjust it away from fully tightened. But it's best just to, if that's the case, fully tighten that one little trimmer capacitor. So that is the response for a spectrum analyzer. I didn't go through all the tweaks. I've spent many hours on this, let me tell you, and that does not make for a very interesting video. So we'll go on, and I'll set up for the first stage 2.075 megahertz alignment, and you'll see how very different that is. Okay, so for the 2.075 megahertz first stage IF, the alignment is immensely simple. There's really nothing to it. You just leave the same attachments for the RF signal generator to the stator of the middle gang of the main tuning gang, and then set it on 2.075 megahertz, and I stop it down to about 7 on the S meter. The S meter is a very good way to do the adjustment. And then the first thing you do is you tune T21 or position 4 in the alignment. Is T21 is essentially the oscillator coil for, and just, I mean, any kind of adjustment at all is just is very critical. Get your best response. Right there. And then you do position number 5 is T6 at the secondary. It is almost no, I mean it's very broad for that. And this one also. That would be position 6, which is the primary on T6. Which is a little bit more touchy, but not very. The whole touchiness is the setting of T21. Just me putting my insulated tool in there has an effect. There we are. Done. So right now it's in perfect alignment. Okay, for the dial calibration and RF alignment, it's same as it is for any other radio. Although it's made easier because there is for example, band 1, there's an upper and a lower band adjustment. Band 2 does not have one. That's just a one size fits all. Band 3 has an upper and a lower band adjustment. Band 4 as well, and band 4 also has an upper, let's see there, and a lower RF adjustment, an upper and a lower antenna adjustment as well. And then band 5, that's the oscillator, is like the just one size fits all. And you use an RMA thing to adjust the impedance and feed the RF signal into the antenna jack, and then rock back and forth and get the best results. This time I used my scope, which is the same as using a VTVM. There's nothing special about that. Okay, and since this was done after the last alignment of the IF and also with the cover on, so that's telling you that we're done with all kinds of alignment things. So this radio is ready to go electronically. This is Hallicrafters Rehabs. Thank you for watching.